For 3-3, we're talking about the distance formula, which the distance formula is actually related to the Pythagorean theorem. And when you use the distance formula, you're basically building a right triangle whose diagonal goes between two given points. So for example, what that's telling us is if I wanted to find the distance between these 2 points, I could use the distance formula, but I could also imagine that this was really just a right triangle, and I could easily calculate how long this was, and I could calculate how long this was, and I could use Pythagorean theorem. So the horizontal leg, which would be the leg that is colored in green, I could find that distance by taking x2 and subtracting x1 from it. And that was how I could figure out how long it was. And I could do the same thing for y, which y is now colored in gray. And I could do y2 minus y1. And that would help me find the length of it. So when you see this weird notation, this line thing, this means absolute value. And absolute value just means that you always make the number positive. Absolute value means you always make the number positive. The distance formula, which is what we're going to be working with today, is equal to the square root of, in parentheses, x2 minus x1 squared plus y2 minus y1 squared. And that's our actual formula that we're going to be utilizing. We're actually going to go ahead and go on to the checkup and just work out those problems utilizing the distance formula. So, like the midpoint formula, I need to label x1 and y1 and x2 and y2. And all I have to do is plug them in the formula. And again, they were really nice and they gave you the formula up here if you couldn't remember what it was or you lost it. And it says the distance is equal to x1, which is 1, minus x2, which is 4, squared, plus y1, which is 1, minus y2, which is 5, squared. Well, 1 minus 4 would be negative 3, and negative 3 squared would be 9. 1 minus 5 would be negative 4, and negative 4 squared would be 16. And 9 plus 16 is 25. And the square root of 25 is 5. Now, you can put this in your calculator, and that is completely fine. If you're going to put in your calculator, just make sure you utilize your parentheses and keep the signs the way that they're supposed to be. So looking at number 3, I'm just going to go ahead and label x1, y1, and x2, y2. So the distance formula says that I take x2, which is negative 1, minus y2, and y2 is negative 4. So notice I have a minus sign and a negative sign there, and you do have to have both of those. Squared plus y2, which is negative 10, minus y1, which is negative 5, and again I do have to have both of those squared. And then you can go ahead and plug that in the calculator. And after plugging it all in, you should get an answer of 5.83. Always round to 2 decimal places. Number 5. On a grid, what is the distance between 2 points located at 0, 0, and 4, 14? So I have x1, y1, and x2, y2. So my distance is the square root of 4 minus 0 squared plus 14 minus 0 squared. And again, your best bet's probably just to plug in the calculator. And typing all of that in is going to result in an answer of 14.56. Another way they can ask you to find the distance between 2 points is to tell you if A is equal to -2,5 and B is equal to 3,1, find AB. When they ask you for AB without a bar above it, they're asking you for how long it is. So it's the same thing. So I have x1, y1, and x2, y2. So my distance is equal to x1, -2, minus x2, 3, squared, plus y1, 5, minus y2, which is 1, squared. And again, it's probably going to be best to go ahead and just plug that in the calculator. And your answer is going to result in 6.40. And lastly, number 9, if A equals 3, 4, and B equals 7, 8, find AB. So again, they're asking you for your length. So I'm going to go ahead and label x1, y1, x2, y2. So my distance formula is equal to 7 minus 3 squared plus 8 minus 4 squared. And plugging that in the calculator is going to result in an answer of 5.66. So that's how long that segment would be.